How's this work out? And I just introduce myself and go, or yeah? Okay.
Pretty much.
Okay.
Just do PowerPoint karaoke.
Okay.
These slides come up, start singing.
All right.
We are live.
All right. So your camera goes like over in there and back and forth. Okay. So I guess we're live. Yay. Thanks for coming to the Greenplum meetup that we're having here in, I guess it's July right now. My name's Scott Kaler. Right now I'm a PM on the management and monitoring team. In the past I've done data sales, and in the past I was also a customer of Greenplum. Okay, and this is kind of what this presentation is about. I'm going to talk a lot about what for me it took to run Greenplum as a customer. So this presentation isn't going to be so much about the internals and features of Greenplum, but as we productionalized it, what we needed to do in order to make it run. Okay. What I'll jump into is some of the background. When I walked into this company, including me, there were 3 other system admins, 2 DBAs, and we had 2,000 servers. Okay. So when I jumped into this company, Greenplum wasn't the only thing I was coming into the company doing. I was doing a whole bunch of other things, right? I was a MySQL DBA, Apache clusters, all sorts of other things, right? So Greenplum wasn't the only thing that I was doing. I wasn't tasked with 100% Greenplum time, okay? So what was going on at the company is the company was an advertising company. We were running an Oracle database. We had an Netezza appliance inside the company, and we did some targeting Hadoop in EC2, and that was actually before they had EMR, and you could do stuff magically in Hadoop on Amazon. And we were actually running one of the biggest Hadoop instances we'd spin up. I think it was like 120 machines in Amazon to do some Hadoop processing and push things down. The issue that we were running into was that we did some of our targeting was done in Hadoop. We did some of it in Oracle. We were trying to do it in Netezza. Netezza was failing us pretty badly. Spoos were breaking down, and it was taking a long time to run. Okay, so the problem was we were really frustrated. It was taking longer than we thought it would to get the work that we needed done. Okay, so we decided to try Greenplum out, right? And for us, our Oracle processing took like a day. Like it took forever to get our batch done. So we tried to get onto the CLIMS and make it faster. All right? And really we went from like day of batch processing to 20 minutes of batch processing for things. Cut some things down to 2 hours. I mean, it was like a world of difference going from our Oracle system to the other system. Because the big problem in the other thing was we'd run it and then we'd have it taking a day was horrible, but then it would come out bad, right? And so our targets would be old and off, so then we'd have to process again. So now we're at 48 hours and our targeting algorithm has to run again, right? And so our profitability went down at that point in time. So this allowed us to churn through everything much quicker. So the use cases we had was, one of the fortunate things was we had a ridiculously easily parallelizable process. So a lot of the stuff that we were doing was roll-ups, like customers and the numbers that they were generating, hits and that kind of thing. We could process that through the database really fast. Parallelizing that worked really well. The other thing that we were doing is we were doing a lot of targeting. So we'd segment users, generate targets. Some of that we were doing in Hadoop, but a lot of that our analytics people were used to using SQL. And they were doing it in Oracle, and it was taking a real long time, and they couldn't try out new algorithms. So Greenplum allowed us to do that too. And the third thing that we did was we were pulling in, we started up a new group that was our data analytics group, and we were made up of roughly 7 business units. We're trying to pull all that data together into a central place and find commonality on it, which was a lot of exploration and that kind of thing. So Greenplum gave us a good place to pull all of that stuff in. this stuff was taking too long to do what we wanted to do originally. Trying to do something like that inside these old clusters just wasn't going to happen, right? So we were able to move forward with Greenplum, with that in Greenplum. All right, so I'm going to talk about staffing, kind of general, the people that we had working on Greenplum. Okay, so the first person I'm going to talk about is the DBAs. So I think this is where Greenplum works really well, as you can take your standard DBA who knows database theory, some modeling, and has reasonable SQL experience. They've done some scripting. They can be effective in a Greenplum cluster and do things, right? You start looking at some of the other products out there, there's a whole new skill set you have to learn in order to start working with massive amounts of data, and you don't need that. So you can be a regular person, and this just levels up the skills that you have and the tools that you have. Okay, and things like your languages, Python, Perl, PGSQL, all that stuff works in there, familiar database rules, all the things the DBA is used to working is there for you, okay? Bonus points if you've used Postgres before, because it's really the same stuff. Okay, the second role that I would say next would be a platform administrator. There's a lot the DBA can do, but once you go beyond that, you start looking at the cluster and how do I make the cluster run well. This is where the platform administrator comes in. Luckily for the platform administrator, you should have clustered application experience, right? I would say for the platform admin, the better person for this job is not somebody that's your sysadmin that's done SAN storage, and that's the background that they have. You want somebody that's done apps across a cluster, okay? So your clustered application experience is a bonus. Knowing how to jump into network, I/O, hardware troubleshooting is another good plus for this person. Greenplum, when I was doing it, was a little bit more raw. And so being able to experiment and try things out, I think, is important for the person that's going to be taking care of the platform. You should be able to dive into the platform and figure things out. One of the great things about this also is there's no custom hardware or funky stuff. We were running Dell servers. We bought standard Dell servers, threw them in a rack, wired them up, good to go. When you're a sysadmin and you're dealing with weird hardware, it makes it really confusing. You have to buy special components. Replacement's a pain. Didn't have to worry about that. Okay. All right, the third group of people that we had, like I would say were core Greenplum people, were our data scientists. And I would say the most important thing that I saw in those people that were effective was curiosity. People that would get in and learn things and try to figure out stuff with the data. Okay. We had all sorts of walks of life. There were some people that did mathematics. We had some, we had people that had backgrounds in a wide variety of sources, right? Some of them had Java experience. Some of them had Python experience. Some had SAS and ended up going with R inside the database. What they really liked was that they could get in, they could jump in at a command line, type something and get quick results back, right? They didn't have to write a program to get data. You get a SQL prompt, you can pull data in. The other part of it was a lot of the people that were working with SAS were used to pulling out extracts of the data and then running their algorithms on little extracts, where in Greenplum, they're able to do it in R inside the database on all of the data. That was very helpful. One thing about the group that I would say was important was that we had machine learning folks and we had data analysts people. And what they did was the machine learning folks would write the algorithms and they would produce results. And they would say, this algorithm ran, it completed, it did its thing, here's the results. And then the analysis people would look at the results and say the why, and they would figure out why that happened. And I think that was a good check and balance for what was going on there and help clarify things. So I would look for that if possible. And I would say for a lot of these roles, sometimes you have one person that's doing all of this stuff, but as your enterprise gets bigger, ideally you can split out these roles into different people and different groups. All right. From staffing, I'm going to jump into building. This is building your cluster. So the first thing I would say, if you're looking at Greenplum, ideally you've got the sandbox, you've ran a little virtual instance, or you're running out in AWS. The reason for that is you get a feel for Greenplum and how it works. That's a great place to start. Stepping up after that, there's, don't hear it talked about a whole lot, but there's some definite use cases for running Greenplum single node, okay? With a single, when you have a single server, some of these servers that are out there, that's a Dell 740 XD. I think it's got 32 disks, 2 cores with a bajillion processors in it, right? If you want to make the most use of that hardware, running parallel Postgres databases is a good way to do that, okay? Another way to do that is you buy, I think that's a 4-core box there. I think that's a 830 if I remember right, and you put an array on the backside of it and you can build more arrays out, right? So there's a very good use case for being able to do all the analysis in a single node, use Greenplum to access all the data in parallel and process in parallel. So what's going to happen after that is eventually you grow beyond a single node or a single system and you start looking at clustering. Okay? For us, the first thing we brought in is a cluster, and then we did some single node stuff after that. Then we started building our own clusters. So the thing I want to talk about when you go to build your own cluster for Greenplum, there's something you need to understand, okay? As a sysadmin, this was the stuff that I was used to. You have a bunch of application servers, they're all running, you have a load balancer, pushes things in at different times, and what you can do is if you virtualize that, the sawtooths kind of match up and it spreads it out, okay? The thing to know is when you run Greenplum, what happens is all these are laying on top of each other, okay? So when you take and try to run this in a virtual environment or a SAN shared storage, what happens, rather than them fitting in the gaps, all the peaks become that much higher, and you create bottlenecks. What Greenplum does is Greenplum, it wants all the resources, okay? It's going to take everything you can throw at it and process it all, okay? So you can run Greenplum in VMware infrastructure or shared infrastructure, but you have to plan on, don't oversubscribe. Greenplum's going to take it all up. Whatever you say it can use, it's going to use, and it's all going to use it at the same time, okay? So that was something we ran into initially, was we tried to do a virtual version, and there was some sharing, and it didn't work very well. If we broke it apart, made sure our resources stayed disparate, it was all right. All right, so I'm going to talk about hardware. When you go to pick out hardware for a Greenplum, this is one of the optimal servers, I'd say, for Greenplum. This is a Dell 740 XD, and it's not that just I belong to Dell kind of at this point in time. Back when I was a sysadmin, we ran Dell hardware. Okay, so I have a lot of experience on Dell hardware. I'm actually Dell hardware certified, so yeah, I can replace motherboards and stuff. So if you take a look at this 740 XD, it's got 32 drives in it. You get SSD drives or, standard spinning disk. Most of the stuff you look at spinning disk because Greenplum uses a lot of sequential read. SSDs are less good at that unless you buy really expensive SSDs. Let's say for your best bang for your buck, look at spinning drives. But if you need a lot of performance and you're willing to put out the cash, SSDs are a viable alternative too. With that, you want a good controller, okay? You're not going to JBOD these and put these on, the cheapest controller that you have out there. You want a nice array that's got good throughput, especially if you put SSDs in there, because if your controller is limiting what your SSDs can do, then your SSDs in the end don't do you any good. Okay, so get a good controller. These boxes take a lot of RAM. Ideally, you can max out the RAM. 10 to 25 gig networking. We tried to do this with 1 gig networking. Doesn't work out too well. Have a lot of networking between your systems. A couple of CPUs. You can get a lot of cores with 2 CPUs now. And I'd say another important thing is to have your backend, your IPMI or your DRAC, so you can get into the system. Even if the system's busy, you can get in through a backdoor into the system and see what's going on. It's also really good for monitoring hardware. An emerging case for hardware stuff is where you have a big box, which is like a 4 CPU box with a lot of cores, and then you start putting external storage on it. Actually, the first cluster that we had was R710s with MD1120 arrays. So we had external arrays and went through that, and it worked pretty well. We eventually ended up going to an architecture like this because it was easier to not have two separate units and it took up less rack space. But at that point in time, you can't expand that and build onto it to add more storage. So there's a give and take there. And a lot of this stuff is, you could run with one CPU, you could run with less drives, you don't have to have that much RAM. The thing I would say that you definitely don't want to cut back on is your networking, okay? You can potentially run like a 4-node system or a small system on less networking, but once you start building that cluster out large and everything has to coalesce to one node, they all start pushing to one node. That 10 gig networking becomes really important, not only for the bandwidth, but you also have, your networking cards have a buffer where it can buffer up information. On 1 gig NICs, that tends to be very small and you start dropping things. So stick with the 10 gig, don't try to skimp there. If you need to skimp somewhere else, you can look at that, but this is probably your good setup. All right, so you decided to build a cluster, got out and bought some servers. This is your first cluster, so you're going to get 3 servers where you want to start at. You're going to put your master on one server and primary on the other 2 servers. It's a pretty good setup. That works really well. And you can be up and running and doing things with this fairly well. And then the issue that you run into is somebody says, hey, but I heard Greenplum's got like this failover stuff that it can do in high availability and all that. You say, okay, well in the budget you gave me 3 servers, so what I'm going to do is I'm going to take, so this is a good idea, all right? So now you say, okay, here's the deal. I'm going to put my standby on the first segment server, and then I'm going to put mirrors on the 2 servers, and they're going to cross mirror to each other, okay? And then I want this to be redundancy and high availability. Okay, the problem with this setup is when the first one catches on fire and burns, and you go down, your second server is now trying to do twice the amount of processing. You fail over to all the mirrors, and you have one server that's trying to do twice the load. I have nobody that I know that goes out and buys a server that says, I'm only going to buy it at half capacity, so that way it can run twice as much stuff than it's running normally. Nobody I know does that. So what happens in this case is you do have redundancy. Your data is saved and you can restore stuff, but the number of people that can actually get queries through there at that point in time is very little because the system is so taxed because you're trying to run things. All right, so that's a bad idea. Don't do that, all right? So the better idea is if you want to get into the redundancy play, get yourself separate servers to do that, okay? High availability, spread everything out, okay? Get 4 servers that way, because what can happen at that point in time is if a server burns and catches on fire, the amount that the other servers take on is reduced. You use what's called spread mirroring. You put 3 segments on one, 3 on the other, 2 on the other one, and they only have to pick up a part of the load. As you get more and more servers, that reduces down. You get it down to the point where there's one mirror that has to take over for the one server that failed out. Now what we did was we actually bought another server that we put in the rack and configured the same as all the other servers. Because what happens is this server catches on fire and burns. You call Dell support. They say, oh yeah, we'll be out in 24 hours and we'll replace that server, okay? Well, maybe you were one of the people that spent like a bunch of money and got short time support, but we didn't. So we had like 24-hour support. And they said, okay, well, we'll be out tomorrow. In the meantime, this is running a little bit slower. If you have another server in the rack that's configured, you can do your recover and tell it all to recover to that additional server. And that will get you back up and running much quicker than waiting for the 24 hours to get another server in. When you go talk to a business unit and say, yeah, well, Dell's on their way out, they'll be here in 24 hours, they don't like that answer, okay? That doesn't fly. All right, so the other thing about building a cluster, when you build a cluster, we have a tool that's called GPCheckPerf. Baseline your system. Okay, you should know when you come out of the gate what the best possible statistics for your server are. All right, what happened a lot was baselining didn't happen. You start running a cluster and then you run numbers and take a look at it, and you don't really know whether those are optimal numbers or not. So it's tough to tell where your problem is when you don't know what your best case scenario is. When you build your cluster, run GP check perf, get your optimal numbers so you know how close or how far away you are from them. The other thing I would say is keep hardware on hand. That goes the same with the extra server. Have extra drives that you can pop in and out. Again, waiting 24 hours to replace a drive is not a good idea. It doesn't cost that much to buy 4 drives and throw them in a cabinet, so that way somebody down there can just pop one in and out. All right, easy button. All right, we've talked about a lot of stuff. If you don't want to do that, we have an appliance. It's Dell EMC DCA. It's kind of the easy button. We have it where we can deploy in Amazon and Azure now, bring a cluster up out there. The other thing I would say is get in contact with Pivotal Data Engineering. They can help you stand up a cluster to make some of these decisions. Okay? All right. So going from building, I'm going to talk about hosting now because we had to put our Greenplum in a data center, surprise. So hosting Greenplum. So this is one of my favorite things when actually Greenplum made this big Hadoop cluster at one point in time, and this was a slide that they came up with. Right? When you get excited about building Greenplum, you're like, oh, it's my cluster, I'm going to make my cluster. There's a lot of stuff that goes on in addition to your cluster. Okay, the first thing is your cluster is going to have a network switch. It's going to be your interconnect. You're going to probably have a top of rack or leaf switch that everything connects to the rest of the network to. You're going to have an admin switch that everything connects to. That's all going to connect back to a core at some place. You're going to have probably a server that you is your safe server to log into. You're going to have your kickstart to build your servers. You're going to have a user directory and network share to get files on the servers. You're going to have ETL to load data into the servers. You're going to have users that want to log into the servers. You're going to have internet stuff that you want to pull down into your servers. You're going to have a data cluster, maybe a Hadoop cluster that you want to bring information into. You're probably going to want to back up your Greenplum. And with all of that, the thing is, Greenplum needs to be able to work with all of these things. And when you go to plan your Greenplum cluster, you need to figure out how it works with all of these things. Okay? You can do a POC where you just stand up your Greenplum and that's it, but it's a whole different world when you start making it work with everything else that exists out there. You should have your kickstart scripts ready to go, know how they work, know how you get access from your Bastion server into the admin console to be able to do things on your Drax. Those are all things you figure out ahead of time. Okay, I'll talk about servers in a cluster. So, okay, when we first made our own cluster, the policy at our data center was when you do a high availability cluster, you take the servers and you put all the servers in separate racks. Because when you run a cluster, what you want to have happen is if a rack goes out, you don't want to have the whole cluster go out. Okay? So we separated, when we built our cluster, we said, okay, Greenplum node here in this rack, Greenplum node in this rack, Greenplum node in that rack, and we tried to start it up, and it failed. Okay, the reason for that is data center at that point in time was built in a north-south configuration. What that means is you have a request that comes in for the internet, it goes to an app server and kicks the information back out. You have a database request that comes in, it kicks it back out. Okay, that's not how Greenplum works. Greenplum is an east-west talker. Okay, all the Greenplum nodes want to talk to all the other Greenplum nodes. Okay, when you have a data center that's built around north-south, usually your top-of-rack switches don't have very much network connectivity because you're doing a lot of processing on the server and then you're kicking a little bit back out. Okay? So that's why our nodes failed horribly, is because everything had small connectivity that went back to the core, and then when the nodes tried to talk to each other, we flooded our core, okay? Which caused other problems inside of our network. All right, so all of your servers should end up in the same rack. Related to that is when you expand out, try to get the servers in the same rack also. We tried once to set it in a rack next to it and then wire everything across, and it was a pain. It was a lot easier for us just to move servers and get everything in the same rack. Okay? So keep your servers kind of local to each other. All right, speaking of east-west stuff, when you're doing ETL, decision you need to make is, are you going to put your ETL boxes on the same interconnect that your Greenplum servers are, or are they going to servers were talking to each other across and flooding the core? If you have your ETL servers existing outside, potential is that when Greenplum goes to load data from push data to Greenplum, you can flood the network because Greenplum can do that. It has the capacity to do that. So you have to think about how that's set up. The even more fun one is when you have a data cluster like Hadoop, can reach parallel to Hadoop, can answer in parallel. We had our Greenplum in a nice cluster, we had our in a nice cluster, and we did a massive data transfer back and forth to each other, and it blew up the network. Okay, so we had to reconfigure things at that point in time because we were pushing too much data. Another fun thing is backup, right? So your Greenplum cluster is 100 times, right? Which is not too far off for a lot of Greenplum clusters out there, that and bigger. So you have a 10 gigabit network connection that goes into your backup cluster. You think, oh, okay, I can do a backup. I'm going to push 100 terabytes across bits into my back cluster. That takes about 25 hours, okay? So you need to think about your backup architecture, right? Either your backups need to take subsets of information, which is what we did. We had some backups that we did to our backup server. We did subsets of information. Look at more than 10 gigabits into wherever your backups are going to. Or the other thing that we did is we did dual load into multiple data centers to get around, so if we had an issue with one cluster, the data existed somewhere else. Okay? And then we didn't worry about backing up that data because it existed in two separate places. So if we needed to revive it, we would bring it from the other one back over. All right, and this is one thing to know about Greenplum clusters. You get a bunch of, R720s or all these drives running. Your Greenplum cluster is going to put out a lot of heat, okay? Make sure you know this because some data centers aren't configured to handle the heat that a Greenplum cluster puts out. The processors and all the drives running all the time will push out a lot of heat. We tried to step down at one point in time. Dell came out with a cloud version of their server called a C2200, 2100, which was a great server except for the fact that the RAID card that they put on there, they use little plastic bolts, and the Greenplum cluster got so hot that it melted all the bolts on the RAID cards. So the cooling fan that was sitting on top of the processor on the RAID card essentially melted off of there, all right, because it gets that hot because you're pushing it all the time. So make sure that your data center can handle that kind of heat coming out of a rack. That's probably not a problem more modern day because you're seeing a lot more architectures like this outside of Greenplum. All right, so the last thing I'm going to talk about is maintaining Greenplum. All right, so we have this awesome tool out there called GPCC. Back in my day when I was administering it, it wasn't so awesome. It worked all right, but it wasn't as great. Now it's a great place to go look and see how load is on the system, if a segment's taking too much traffic or what's going on the system. So I think that's your first bet now. What I would say as somebody that's running the cluster, you need to have, we had a Nagio system that was out there that was polling and checking to make sure that the servers were good. Everybody that's running a Greenplum cluster should have something that's checking to make sure that the cluster is running at a system level. You should also have a check out there that goes into your cluster and says, I want to run a small query and get a result set back, okay? And then have a timer on that. So that way you know if the system is taking too long to respond to a SQL query, all right? And then throw an alert out. You should also have graphs on traffic at a system level. We found these really helpful for if something in the network was causing one of the systems to skew. Now you could get a lot of that information out of GPCC, but there's other things like we had specific CPU skew that we could pull out of. These were cacti graphs that we used. The thing that I will mention on these is you have to be careful with RD graphs or other tools out there. As the dates get out further, they tend to average the data. So you might see spikes go away as they pull the data in. And I would also say you want to set up email alerting, okay? Greenplum's got a great facility to spit out alerts when things go wrong in the database. So turn this on, and you'll get hit with a lot of email, okay? Because it alerts on a lot of things. So the next thing you do is you set up a filter, okay? And filter the email so you're getting the critical stuff that's coming through. What we did was we had certain things that everything would come through and it would highlight certain errors that would pop up, right? So those would get flagged as important while other ones were just more lower level. Okay, so when you have a cluster and you say you want to schedule for downtime or a spot where you want to throttle traffic to do things, a lot of people kind of harumph at that and say, oh, why do you want to have a cluster with downtime? All right, so scheduling downtime is important. Scheduling maintenance is important. If you go someplace and they have a bathroom and they say that they only maintain it when they need to, or somebody has a problem, you probably don't want to use that bathroom, right? If they say every couple of hours we go in and take care of it and clean it up and make sure it's good, that's a good place. You probably want to use that one, right? So that's why in your Greenplum cluster, you shouldn't be waiting for a disaster to happen before you go in and clean it up, right? Keep regular maintenance on what you have going on. This regular maintenance is going to be, if you can schedule a window, which is what we did every 2 weeks, we had a maintenance window that we could go in and do things. And sometimes it was nothing. Sometimes everything was running great. We don't have to worry about the maintenance window. But everybody knew Tuesday night at 5 o'clock, the system might go offline and we're going to potentially do like a defrag on the drives, or maybe we know that the learn cycles on the RAID cards is going to come up real soon and we want to preempt that and run them while it's not processing things. Okay, so you can do some things to take care of the cluster during that space. And it's good for when you have upgrades in that, rather than saying that you're going to do an upgrade and having to schedule something in the middle of everything else that's going on. If you have a window that's reoccurring, then you can do that during your window. Okay. All right. Things that we found ourselves doing a lot. Analyzing tables. Initially, we set it up to auto-analyze the tables as the data went in. That was bad. That affected our performance. So we turned the auto-analysis off, and we expected the developers to analyze things as they went in. For the most part, that worked all right. Okay, but there's people that put the data in and didn't get it done, so we'd have to go in and analyze different tables to make sure performance was good. What you don't want to get into, so this is the SpaceX rocket, right? They should be really damn happy they landed on the platform, right? Your statistics do not have to be so good that you land dead center on there, so don't analyze every time one tuple goes into the database, all right? There's an error of margin that's okay. Land on the platform, not in the water. You don't have to land in the middle of the platform, okay? So that was our goal, was to stay within, if we saw tables change, maybe like within 5%, 5 to 10%, we do analysis. Or if we saw skew, or there was lots of loading, we might do analysis. It wasn't every time somebody inserted something they had to do an analyze. Okay.
The purpose of analyze is for, in case people don't
Oh, the purpose of analyze is for computing statistics on your table so that the optimizer knows the best way to go out and get the data. Okay? So you want to have pretty good statistics on going out and getting your data. They don't have to be perfect when you're talking about a table that has 7 billion rows in it. You don't actually need to know that it's got, 6,999,000,000, blah, 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 right? You want to be within a close to that. There's an awesome tool out there called AnalyzeDB that does this in parallel. Make use of AnalyzeDB. This didn't exist in my day. We had a bunch of scripts to manually do all this stuff. AnalyzeDB took care of all that. Okay. The other thing we did pretty often during our maintenance window was vacuuming the database. It's important to understand vacuuming. There's a tool out there that will say how bloated your tables are, how much extra space is in your tables. So if you think of your table as cheese, okay, you keep adding more and more, your block gets bigger and bigger. What happens is Eventually, some of the cheese you don't need anymore. It gets kind of moldy and aged, and those are records that you don't need in there anymore. So you can run a vacuum, and what a vacuum does is it takes that out, okay, and it leaves space in there. So ideally, in your block of cheese, then you can start putting other cheese inside the little holes, and all your goodness is there. Okay, and that's good to stay on top of. There's also an option that's vacuum full. So the problem with the Swiss cheese thing is maybe your data is too big to fit in a certain hole, so it can end up kind of fragmented, and you can get a weird mix of cheese, just kind of mushing it all together like that. So if you run a vacuum full, what it'll do is it takes and essentially recreates the table and rewrites the data. Okay, the important thing to understand is you have to lock the table so that you can do that. You're moving it from one file to another file, whereas a normal vacuum is just setting flags and cleaning up what exists there, and you can still access the table. So you have to figure out when to use those, what's the right time to use them. All right, so I think this is the last thing I'm going to talk about. There is, because GPCC wasn't where it was at initially, where it is now, we created our own tool. And what this tool did was it created a contract between the admins, the DBAs, and the users, and made everything visible. So this was a tool that we took and we put on a screen in front of every group's area. And zoom in here a little bit. The great thing about this tool was it lets you know if a drive was down, so that way you could get a hold of the sysadmins. So potentially I'd get alert. Sometimes I'd have somebody come say, hey, Scott, the little button turned orange. You need to go fix that. Space, you'll notice that there's a used, a free, and a reserved there. And the reason for that is you don't really want to go above 70% inside a Linux cluster. So we had a reserved space, and the little pie could get bigger. And if you cut into the reserved space, it turned orange. Ideally, that let everybody know, don't do that, don't get into there. And it was a visual thing everybody could look at day to day. And then on the right here, you see server load. So everybody could see what was going on the cluster. Greenplum's a parallel system. So we had these little speed gauges. And ideally, when the system's running, everything looks about the same. Okay, and ours, there is a little bit of difference. You can see down here at the bottom, these gauges are down a little bit lower. This is because in Greenplum, while it's ideal to have your servers the same, they don't have to be the same. So these were R710s, the first set of servers here. And down at the bottom, we had a new generation R720s, I think. So they processed queries a little bit faster. All right, so the load on those servers was a little bit ones that were up top. You see one I was talking earlier about the replacement server. That one's like down at the bottom because it's the replacement server, and we would recover to that one. And the really important thing about all of this was this part right here. So this was our promise to the people that were doing queries that we would stay on top of server stuff. This was the wall of shame, okay? This was how long queries took to run. This is really handy when you have it up on a big screen by a group of people, and they say, hey, you know what? You're idling transaction for 10 minutes. Well, why are you idling? Why is your query idling? And, oh, I need to kill that session. I'm not doing anything. I'm just letting it hang there. Where it became more important is if you had a process that ran for like 6 hours, that they would know and they could see it and go talk to that person. The one thing I would take away from this, the way we implemented this was we had it by username. All of our users could log in. And the problem with that was that ended up being, we had a lot of applications doing things as users. So when Brad left the company, 6 months in, Brad was still running things inside here. So the idea was that, oh, we see Brad's things taking a long time, we'll go talk to Brad. Well, Brad no longer works for the company, nobody else took over his stuff, it still runs as Brad. So what we did later was a lot of our processes that were application processes got application users, that way we could associate them back and forth. So I would say the username thing worked all right. I think it worked great for our data analytics folks when we saw that they were doing crazy things, because then we could go to those folks to figure things out. But for process-specific things, make sure that the user is related to that process. All right. That's the end of what I got. So questions? Anybody have any questions on anything?
Can you go back to the slide with GPCC and show how that compares to what you sort of dreamed up many years back?
Okay. So I'm going back to the GPCC piece, and this is to compare to what it was that I dreamed up. Okay. And one of the problems is this is an earlier version of GPCC than what's currently out there. But you can see you have CPU load, and you'll see for the cluster what the CPU looks like for all the different systems in the cluster. And now it's got memory and disk I/O and load and network. The reason that I created mine that had some of this similar stuff but was different was because back in the day that was a flash application, and to run it on a lot of our stuff just didn't work. Like to put it on our monitors or system that did all that, it didn't work for that. This also, it used to be that I believe it pulled every time that it ran and every time that you refreshed it. And the new GPCC is better about doing this on an interval and refreshing the data, which is what the thing that I created did, is it ran the information that it got once every couple of minutes. So you're not hammering the database with lookup queries on statistics all of the time. So.
If I want to build a Greenplum with 100 CPUs, would it be better to have 10 servers with 10 CPUs or 100 servers with 1 CPU? Or
Okay.
somewhere in the middle? How would you pick?
All right, so the question is, if I wanted 100 CPUs in my cluster, would I buy the monster box that has all the CPUs in one cluster, or would I buy, like one machine that's got 100 CPUs, or would I be better off buying a bunch of one CPU machines? Like,
Or even VMs with a quarter of a machine and have
right, or
100 VMs.
yeah, there's a bunch of different ways to slice it that you could look here. So some of that, I believe, is going to depend upon what your query structure is going to look like. Right, some of your queries are going to be more parallelizable. So I think there's a use case for having multiple machines being able to do that. That's also going to be pulling data off of disk, right? So while you might have 100 CPUs, if you only have a few disks in one machine, you're not going to get the network band or the I/O bandwidth that you need, right? So usually going out more machines helps. Fault tolerance wise, one of the issues that you run into is the less. So even if you had 100 out there, you lose one, then you've lost 25% of your processing power, all right? So I'm trying to think, in that case, I would probably aim for more servers. And at the point, I would definitely not go for any sort of specialized hardware, right? If you're trying to get funky in order to make your cluster be uber powerful, don't do that. Get standard stuff and try to keep it all the same. So like in this case, I would have just gone with standard two core, maybe 12 CPUs. Yeah, 2 CPUs, 12 cores per type system.
One CPU.
So I wouldn't go one CPU. The reason for that is if you have one CPU, you can really only one segment on that box, right? Because it's going to be a database running, and you don't want to have multiple databases running on one CPU. The other problem with that is, and while Greenplum's a parallel system, what can happen is you can have a query that goes into the system that does something similar to a count unique, where it has to move it to, it skews to a segment, right? At that point in time, if you have skewed, if you have one, there's no way for anything else that's underutilized at that point in time to help out. So yeah, it's a balancing act. You don't want to have, you kind of want to land in the middle, I'd say. Not all one big box, not a billion little boxes, right? Find somewhere in between. And usually the in between is the cheaper version rather than going one way or the other. Your data on all your drives, right? Um, 12 nodes is mirroring set up and don't have to worry about servers having to take on multiple mirrors, right? Let's see, other considerations. Staying with even numbers. Usually when you deploy in like maybe a 4, 8, 12, 16, like 16 fits in a rack pretty good. And when you do your mirroring numbers and stuff, it's easier to have an even number. Don't try to expand the cluster by one node. Expand the cluster in chunks, right? Add 4 nodes to the system, add 8 nodes to the system. The downside to adding one system is now you're trying to remirror everything while you're sliding one system in, and that can create some that work. Plus, if you're going to the effort of adding more servers into that, your sysadmins don't want to just add one server to next week, add another server to next week. They would rather just do it all at once and make the configuration change at once.
How much outreach and education did you have to do for the users of the system, from people driving queries, writing applications? Was it pretty comparable to what they'd experienced before from the level of the database up, or did you have to, was there more dialogue about, no, you have to restructure your query this way, or think harder about how you land your data?
Okay, user outreach and teaching people to use Greenplum.
Outside of those stack roles that you identified.
Okay. Yeah, outside of this, yeah. Using the database, how much training? Parallel query, we had a FAQ on queries that don't parallelize well, right? They'll run, but they're not the best query to run in the system to make the most of it. Then I would say every year or every 2 years. So we did that for a long time, and we still got a lot of bad queries in the system. And the reason for that was we were inside the company trying to preach out to everybody. After about 2 years, we brought in Tushar, who's here in the room, and another guy, Zach. And they were the pivotal experts that came in and said the exact same things that we were saying. That was like important information for everybody to know, and they all took it to mind, and our utilization this. So while I think it's important for you to kind of continuously preach this stuff, I think it's also good to bring in an outside source to come in and say, hey, we've been to A, B, C, and D, and this is what we're seeing them do, and this is good for your cluster.
So you explained how the architect, like how you should build your data center or the rack configuration along with the switches. Like if you run this somewhere in AWS or some cloud system, is there a way to figure out what are the bottlenecks that are there on a system that I can't look at? And how do I architect my Greenplum
Yes. So let's see, some of the introspection into the cluster in the cloud, and potentially get into VMs and stuff like that too, where people don't have access to see what's going on. That gets a lot tougher. Luckily, there's some stuff in GPPerfMon that will help you see what's going on. We've actually found that very helpful working with customers that can't get to, because like I had all these system graphs set up, right? There's customers that I've worked with where we've said, hey, can we look at your system graphs? Do you have them? Oh yeah, we've got an agent, but I have to talk to this person who has to talk to this person, who has to give me rights to talk to this person to get that graph for you, right? But in GPPerfMon, we've got a lot of those statistics that you can look up and get an idea of things. That's useful in AWS, I think, as an abstraction. And I would say having monitoring agents or some sort of like Datadog or something like that built into your cloud infrastructure will help you a whole lot. I think some people don't bother doing that, and they need to have that information, right? They just assume in the cloud it's going to run perfect, and more often than not in the cloud it doesn't run perfect. It's just somebody else's hardware, right? And it breaks too.
To the previous question about training, did you have situations where the management or maintenance of the Greenplum cluster was kind of dictated by the business intelligence tools that the analysts were using, or the way they were writing queries?
So maintenance is related to the way that people were, or training is related to the way people were using.
Yeah, like, does a company that's using Tableau to query Greenplum a lot sort of tune their Greenplum differently than someone that, yeah.
So would you, I guess one of those questions is, would you tune your Greenplum differently depending upon the users and how they do it? And actually we did that, okay? So we had one Greenplum where we were trying to do the data analytics in it, so that whole aggregation of all the different data, along with a business use case, which was this targeting stuff. And initially we tried to do that all in one Greenplum. And that was a problem because, like any other application, when you try to do two drastically different things inside of one system, I think that's the problem with Hadoop right now, right? Is it's supposed to be this platform that does everything, and people use it for multiple things. Same thing for Greenplum, is if you try to do two distinctly different use cases in one system, it can cause problems. So the problem that we saw there was a lot of churning and rolling up of data. And we had the data scientists coming in and saying, hey, I'm going to write this algorithm, or some of the better stuff was, okay, I'm going to use PL Perl to go out and scrape Yelp, pull in information and process it, right? So how much processing that uses in the system is not something that's a day-to-day thing. And then you also have a business use case where someone's looking for things to be repeatedly done. So yeah, I think you need to split those apart, and then the people need to be trained differently to look at different things in the system.
Yeah, can you say something about platform security and application security?
Platform security. So that goes back to when you're first putting your your Greenplum in the system.
Open up the newspaper and find that somebody has stolen all your.
Yeah. So one of the nice things about Greenplum initially is that when you deploy Greenplum, sometimes you can only put a keyhole through the system that's your SQL prompt, right? The rest of the system can be behind a firewall and off of the network. So that reduces your vulnerability footprint a lot to just the SQL interface. At the same time, you want Greenplum to be able to reach out and pull data in. So sometimes that can get kind of complicated in what kind of network access you allow in and out. So I would say for a lot of people, that's a pretty complicated maze of things to go through. And that's where things like getting help from PDE or the data engineering, or buying a pre-bought, pre-canned thing can help out in security stuff. We had to do a lot of work in that area to try to tighten things down. All right, anything else? All right, I guess we'll call it then. Thanks.